Welcome to Review and Preview Problems 1031 to 1037 in the CCG book. 10-36 says, assume point B is the center of the circle below. Match each item in the left column with the best description for it in the right column. So looking at segment AB, I would match that and say AB is the radius. Line segment CD, I would match with CD is a chord, so it's connecting 2 points on the outside of our circle. Arc AD would be a semicircle. Angle CDA would be an inscribed angle. Arc AC would be a minor arc, and angle ABC would be a central angle. 10-32, the figure below shows two concentric circles, which means one circle inside of another. What is the relationship between AB and CD? How do you know? So they are similar, for sure, because they're both circles, and CD is enlarged, or we also say it is a dilation of AB from point P. Which has a greater measure, AB or CD? Well, these are both connected to the same central angle depending upon the circle you are looking at, so they actually have the same length. If the measure of angle P is 60 degrees and PD is 14 degrees, find the length of arc CD. So we want our circumference of our circle, which is 2 pi r. Our radius is 14, so 2 times 14 pi is 28 pi. We then only want a piece of our circle, so 360 divided by 60 gives us 6. So if we divide 28 pi by 6, we get approximately 14.7 units. 10-33, in circle Y below, assume that the measure of arc PO is equal to the measure of arc EK. Prove that PO is congruent to EK. Use the format of your choice. So to prove that those arcs are congruent, we could state that, let's look at it from the radius first. OY is equivalent to, so OY is congruent to YK, which is congruent to YE, which is congruent to YP. So if we have two triangles that have congruent sides, it means that our base angles are congruent, which would mean our central angles must be the same. And if our central angles are the same, we know that our arcs are the same. Because if we have congruent triangles, it implies that we have congruent parts. We could have wrote a formal proof for this, 2-column proof, or just a flow chart. So now that we've thought through it, we know that all radii are congruent, so we can make a reason for that. We then know our central angles are congruent, so angle PYO is congruent to angle EYK, and that's because our arcs are the same measure. So based upon side angle side, we have triangle EYK is congruent to triangle POY, side angle side congruency. We then, our last and final statement is that line segment PO is congruent to line segment EK, because when we have congruent triangles, we have congruent parts. 10-34 says, while working on the quadrilateral hotline, Joe Beth got this call. I need help identifying the shape of the quadrilateral flower bed in front of my apartment. Because a shrub covers one side, I can only see 3 sides of the flower bed. However, of the 3 sides, I can see 2 are parallel and all 3 are congruent. What are the possible shapes of my flower bed? So if we have 4 congruent sides and 2 are definitely parallel, it could be a rhombus. So it must be a rhombus. Could be a square. (1035) says, compute the volume of the solid shown below. So if we want to take the volume, we need to find the area of our bases that are parallel to one another. So to find the area of a sector, we need to find the area of our whole circle, which our radius would be 2. So pi 2 squared would give us 4 pi. If we're talking about a 45-degree angle, we take 360. We divide 360 by 45. So we know that equals 8. So if we take our area, divide that by 8, we get 1/2 pi. We then want to multiply that by our height of 4. So we get 2 pi, which is approximately 6.28 feet squared for our area. When we multiplied it by 4, it was this height, so we want to make sure our label is cubed because this is in fact our volume. 10-36, for each pair of triangles below, decide if the triangles are similar or not and explain how you know. If the triangles are similar, complete the similarity statement. Triangle ABC is similar to triangle blank. So looking at these two triangles, if I take 34 and 56, subtract that from 180, I know I have a 90-degree angle. I then know that I have angle similarity, but remember, when your angles are similar in your triangle, it doesn't prove they're congruent, but it absolutely proves that triangle ABC is similar to triangle LKH. Looking at B, we know that this side is 6. Our sides don't match up. We have a 9, a 4, and another 6. So we would say there is not enough information to be able to tell if these are similar. Looking at letter C, I know that vertical angles are congruent. I also know if I have parallel lines, my alternate interior angles are congruent. So by angle similarity, we can in fact say that triangle ABC is similar to triangle EDC. 1037, multiple choice. Which equation below is perpendicular to y equals -2/5 x minus 7 and passes through the point 4, -1? So remember, in order for it to be perpendicular, our slopes must be opposite reciprocals. So the first thing that you could do is you could solve all of these equations for y by using the inverse. Divide by -5 gives us a positive 2/5. They're inverses of each other, but not opposite. So when we subtract our 2x, divide by our 5, our slopes are the same, so B would be parallel, not perpendicular. If we subtract our 5x, divide by our 2y, -2, our slopes would be perpendicular. We then could quickly plug in this point to check and make sure that it was a true statement, and we would see that C is the equation that works.